It is my distinct pleasure to present to you lesson 2.2, factors. Wait, we're not on 2.2. Well, we are now. Lesson 2.2, factors. Your lesson objectives for this particular lesson. Find the common factors and greatest common factor of two whole numbers. Fun, fun, fun. Common factors and greatest common factor, whoa, also known as GCF. Also, identify prime numbers. Ooh, more fun. And composite numbers. We're really getting into it now. Here's our vocabulary for this lesson. Factor, common factor, greatest common factor, prime number, and composite number. Let's get right to it. Learn. Break down whole numbers into factors. And then we see 6 soccer balls, and it says 1 times 6 equals 6. Can 6 be divided exactly by 1? So remember, division is about kind of sharing or making equal groups. So let's take a look. Got 1, 2, 3, 4, 5, 6. So divided by 1, that means 6 divided by 1. How many groups of 1 can I make? So I can make 1 group, 2 group, 3 group, 4 group, 5 group, 6 group. So can 6 be divided exactly by 6? Yes, so 6 is a factor of 6. 6 is the product of 1 and 6. 1 and 6 are factors of 6. When a number can be divided exactly by another number, there is no remainder. That is very, very important. So little Timmy, or whatever his name is, told us something very important there. So the factors of 6 are basically all the numbers that you can multiply together to get the product 6. So 1 is a factor of 6, but you know what? 1 is a factor of everything. So it's usually not that interesting when we're talking about factors, because 1 is a factor of anything, because 1 times anything is just itself. How about 6? 6 is obviously a factor of itself, because 1 times 6 is 6. Hopefully on the next page they are going to introduce the other factors of 6, sort of. All right, well, let's go to think about it in terms of this. Can 6 be divided exactly by 2? Yes, so 2 is a factor of 6. So 6 seashells. Can we make groups of 2? Here's 1 group of 2. Here's 2 group of 2. Here's 3 group of 2. So yeah, we can divide it by 6. Or 6 could be divided by 2. Yes, so 2 is a factor of 6. Can 6 be divided exactly by 3? Dividing exactly means that, I thought these were seashells, I guess they're turtles. So we don't want to break any of the turtles in half, right? We have to have groups of entire turtles. Not okay to cut off a turtle's tail or head or anything like that. Obviously not. No turtle soup here. No. So can 6 be divided exactly by 3 without hurting the turtles? Yes. Here's 1 group of 3 turtles. Well, here's another group of 3 turtles. So 3 times 2 is 6. 3 and 2 are in fact factors of 6. 6 is a product of 2 and 3. 2 and 3 are factors of 6. However, let's think about, can 6 be divided exactly by 4? Well, no, because I can get a group of 4 and then I have 2 left over. And once again, I do not want to break open any turtles. So the complete factors of 6 are 1, 2, 3, and 6. Those are its factors. Now you might be like, well, who cares? But they come up a lot, especially with fractions and also with just multiplication in general. Moving on to the guided learning here. Find the factors of 32. So 32 equals 1 times 32. So 1 and 32 are certainly factors. 32 equals 2 times 16. So 2 and 16 are factors as well of 32. 32 is equal to 4 times 8. So 4 and 8 are also factors of 32. Just thinking out loud, the way I do it is I always kind of start like this, where I list, I don't usually write this part, it's kind of extra, but I'll write 1 and then 32 on this side. I usually make like a T-chart. And then I'll do 2 and then 16, and then I'll think about, well, does this 3 work? I look at 32, and I know something about what's called divisibility rules, but we'll talk about that later. Leave a comment in the video if you want to know more about divisibility rules. I'll give you 500 extra points. How about that? Because I think they're interesting, but it's kind of a tangent for me. So does 3 go into it? Well, I could do the calculator to see that no, 3 does not go into 32. Not exactly, not without cutting up one of those turtles, and God forbid. So 4, well, it tells me right here, 4 times 8 is 32. Yeah, that checks out. Let me try 5. I know that 5 is not going to work because 5 times 6 is 30, and then 5 times 7 is 35. So 6, I know 6 times 5 is 30. We just said that. And 6 times 6 is 36. So no. 7 is also not going to work. 8, well, yeah, 8 works. 8 times 4 is 32. But look, I already have 8 over here. So one thing you should know about multiplication is the order is not important in multiplication. You can change the order and you still get the exact same product, the same answer. So the factors of 32, say it with me, are, that's right, 1, 2, 4, 8, 16, and 32. Let's see what that looks like. And where's my pen? Where's my pen game? Dude, where's my pen? That is my pen. Pen. All right, now I'm good. Desperate times call for desperate times. So we have factor 32 are, so we usually write them as kind of factor pairs so that we can do a rainbow method. Very cool, very cool. Oops. What is it, 32, right? Okay, so there's the list. If I was to ask you to list the factors or find the factors, usually you list them like this from least to greatest. When you list them like this, you can kind of also do what's called the rainbow method, where you try to match up the factor pairs. That's really useful to see if you have any that are missing. So let's do that, see what that looks like. All right, so we get a nice view there of our factor pairs. Very, very nice. Let's try the next one. Boop. The next one, find the factors of 24. Well, how are we going to do this? Let's use my favorite method, the T-chart transition. Number 2. Let's write this one down in our notebook, shall we? Alrighty then. Ooh, sorry, my chair keeps moving. So I'm always gonna, let me show you how to do this. This is my good friend, the T-chart. If I ever see you make one, I'll give you a bunch of points on the spot because it's awesome. The T-chart is so cool for this. Okay, so I'm gonna start at 1. It's a systematic approach. I'm always gonna start at 1 and then go down from here. So 1 times what is 24? That's right, it's 24. All right, now my next one, I'm going to try 2. Let's see, 2 times 12 is 24. Just cut 24 in half. All right, let's go to 3. And if you said what's 24 divided by 3, well, that's 8, isn't it? Of course. Extend the line. 4 times 6. Okay, 5. Is 5 going to work? Let's see. 5, 10, 15, 5, 10, 15, 20, 25. No, 5 not going to work. I could try 6, but look, I already have 6 right here. Therefore, this must be all of the factors of 24. By doing it in the systematic way, I make sure I don't miss any. So that's like very cool. Very cool stuff. Very cool stuff indeed. Alrighty then, moving right along. Let's list them out then. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Quite a lot, quite a lot. 24 is one of the numbers with the most factors. Therefore, when we're practicing things like simplifying fractions, you can bet that 24 is going to be your denominator a bunch of times. All right, join me on page number 58, the next page. Zoom, zoom, zoom. Learn how to determine if one number is a factor of another number of another. So is 3 a factor of 12? Is 3 a factor of 12? To decide, take the big number, the 12, and divide it by 3. 12 divided by 3. Right here, it shows you how to do that with long division. I think it's really important to learn long division. However, for this lesson, I want you to learn about factors, and students have a lot of trouble with factors. Therefore, I don't mind if you use a calculator for this. You do 12 divided by 3. And this is helpful, though, because it sees there's no remainder. So let's take a look. 12 here is what's called the dividend, which is the big number. And outside here, that's called the divisor. So I would ask, how many times does 3 go into 1? No times. How many times does 3 go into 12? 3, 6, 9, 12. So that's 4 times 3. So that's why the 4 is up here. And the quotient, which is the answer to a division problem. Then the next step in long division is to multiply to see if you have anything left over. So 4 times 3 gives me exactly 12. And the subtraction is to find out if there's a remainder. So 12 minus 12 is 0. So that means there's no remainder. So we'd say can be divided, 12 can be divided exactly by 3. So therefore 3 is a factor of 12. Is 5 a factor of 16? Same process, take the 16 and divide it by 5. So we know that 5 times 3 is 15. So that's why the 3 is right there. That's the closest without getting over, kind of like the Price is Right. So let's see if we have a remainder. 16 minus 15 means we'll have 1 left over. That means if I want to divide 16 into groups of 5, I'll have 3 groups of 5, but then I'll have 1 thing left over. I'll have 1 left over. It won't quite. I think that's what it means, unless it means that if I have 5 groups of 3 with 1 group of 1 more. Well, yeah, that's exactly what it means. I have 5 groups of 3 with 1 left over, or 3 groups of 5 with 1 left over. But I would not get to 16 unless I wanted to split that one up into different pieces, but I don't want to do that. So 16 it cannot be divided exactly by 5. Therefore, 5 is not a factor of 16. Find the factors of each number. Very interesting. Find the factors of each number. We're going to do that. But we just did that. So you're going to do that 3, 4, 5, 6. I guess it's guided learning, so maybe we'll do it together. But yeah, I don't want to waste your time with that. I mean, it's not waste. Do it. Make sure you do it, and pause the video right now and do it. All right, did you do it? Good. So what are the factors of 12? Okay, that checks out. I don't want to just tell them to you because then I think you'll be like, you won't do it. So do this 3, 4, 5, 6. Boom. Next thing, talk about common factors. Common factors. This is kind of when we look at 2 numbers like 8 and 12. Well, if you list the factors of 8 and list the factors of 12, it's interesting to take a look at what factors they have in common. And it's more than interesting, it's very, very useful. Extremely useful when simplifying fractions and when solving some interesting like pattern thing problems. Well, whatever. So take a look at what they did. I love this kind of thing. They made lists, kind of like our list before. So they made 2 lists. They made a list of, well, here they go, the factors of 8 and the factors of 12. Once again, factors are the numbers that you multiply together to get your product, which is your answer in multiplication. So factor times factor equals product. So they listed the factors of 8, 1, 2, 4, and 8. And they listed the factors of 12, 1, 2, 3, 4, 6, 12. And why are there green circles around some of the numbers? Think about it. Think about it. That's exactly correct. They put green circles around the numbers that are in both lists, right? They are common factors. The common factors of 8 and 12 are 1, 2, and 4. So let's talk about that. It's not very interesting that they have 1 in common because we already know 1 is a factor of every single number. So it's just not that interesting in terms of like what's it going to tell us. I mean, like, yeah, if you divide it by 1, the answer stays the same. So if you multiply it by 1, the answer stays the same. So it's really not going to tell us that much more. 2 is useful. In 2, if it's a factor of 2, that means it's an even number. So every single even number has 2 as a factor, which is interesting, which means that you can divide it in half. So that's like what it means to be even, is means you can split it in half or divide it by 2. And then 4 here, 4 is going to work as well. But you know what? 4 is kind of like, out of all of these factors that they have that are common factors, 1's a common factor, 2, and 4. What's the greatest of those 3 numbers? Yeah, it's 4, isn't it? That's the greatest common factor. That's going to come up pretty soon. Hey, look, it's number theory. All right. Find the common factors of 9 and 36. Oh, look, they gave us the factors. All you got to do is list them and then find the common ones. Oh, my gosh. And then we have some yes or no questions. And then we're going to find the common factor of each pair of numbers. And then, let's see, what are we going to do then? Then we're going to find the GCF. Oh, we kind of did that. Oh, they have this method. All right, we'll do that later. Because this, already coming up on 15 minutes. GCF. That'll be the next video, GCF. And prime and composite. Yikes, what a monster of a lesson. We'll get to that also. And a hands-on activity. Ooh, that sounds like homework. Ooh, is this the sieve of Eratosthenes? Yes, it is. My favorite. The sieve of Eratosthenes. And then a let's explore. This is one monster of a lesson. And then let's practice. Oy, you've got a lot of homework tonight. I guess I do too, because I got to make a bunch of videos. All right, well, I'm giving this to all 3 grades because this is so fundamental to like what you need. This is like possibly the most important math lesson you've ever had. Until the next one. All right, well, I promised I would find the common factors of this next one before moving on. So that's this. Here we go. Find the common factors of 9 and 36. So they've listed here. We'll walk you through it. So I want to list the factors of 9. Well, that's 1, 3, and 9. Because it's kind of interesting. This is one of those numbers that has 3 times 3, or we'd say 3 squared, right? 3 to the second power is 9. So does it have 3 factors or 4 factors? I guess you'd only say, or you would only say it has 3 factors because you wouldn't count this one twice. Its factors are 1, 3, and 9. 36 has a ton of factors. So we know that 1 is going to go here because 1 is always a common factor. So that's always a common factor. 2 is not going to be here for 9, but it is going to be down here for 36. But it's not a common factor. 3, let's see, there's a 3 there and there's a 3 there. So they're both going to have a 3. So that's going to be their second common factor. And, well, I know 9 is not even. So no other even number is going to work for 9. Right? 9, I can't divide it by 2. I can't divide it by 4. I can't divide it by 6. Could I divide 9 divided by 9? Yeah, you betcha. So 9 is a factor of 9. So the common factors of 9 and 36 are 1, 3, and 9. And they don't ask it here, but if I was to ask, well, what is the greatest common factor of 9 and 36? Well, that's going to be 9. Let's quickly do this. Number 8 is 5, a factor of 20. Yeah, right? 5 times 4 is 20. 5, 10, 15, 20. So 5 is a factor of 20. Number 9 is 5 a factor of 35. Well, if we can skip count by 5 and get to 35, then you betcha 5, 10, 15, 20, 25, 30, 35. So, yep, 5 is a factor of 35. Is 5 a common factor of 20 and 35? Yep. Is 2, no, so number 11, is 2 a factor of 24? Well, 24 is an even number. It ends in a 4. It means it's even. So we already know that 2 is a factor of every single even number. So yeah, 27 Well, that 7 is an odd digit, meaning 27 is an odd number, meaning 2 will not be a factor of 27. So number 12 is no. Number 13, therefore, can it be a common factor of both of them? Well, it's a factor of 24, but it's not a factor of 27. So 13, no. 2 is not a common factor of 24 and 17. Number 14, is 3 a common factor of 30 and 40? Well, I know 30 divided by 3 is going to give me 10, so that works out. But 40 I cannot divide evenly or exactly by 3, so no. Is 4 a common factor of 96 and 48? Yeah, take my word for it, it is. Well, okay, so 12 times 4 is 48. And 48 times 2, right? If I double 48, I get 96. So 12 times, or no, so 24 times 4 is 96. I think that's how that works. All right, find the common factors of each pair of numbers. Okay, so you're going to have to list them. So for 16, obviously 1, 2, 4. Oh, no, it's not common. Yeah, it is a common factor, isn't it? And then 6 is a common factor, and then 12 is not a common factor. So 1, 2, 4, 12. Number 17, 12 and 16. Well, I know 1 is a common factor because it's a common factor of everything. 2, yes, because they're both even, so 2 is a common factor. So 1 and 2. And then 4 will work, so 4 is also a common factor, and that's it. For number 18, what do we have here that are common factors? Well, they're both even, and they're both numbers, so 1 is a common factor of everything, so we have 1. In terms of even numbers, 2 is therefore a factor of it. So let's think about this. Would 3 work? Yeah, 3 would work as well, because I know 54 divided by 3 is 18, probably. Yes, 18. So that works. How about 6? I know 9 times 6 is 54. So 6 works. How about anything else? I think that's it. So the numbers I just said. Finally, 45 and 96. Well, 1 certainly works. And I'm pretty sure that's probably almost it. Maybe 3. Yeah, 3 would also work. So 1 and 3 are our common factors here. I don't think 6 works. I don't think 9 works. There you go. All right. Find the greatest common factor of 8 and 12. Well, there's two methods. The first method is what we did before, where you make a list of each one, and you circle the numbers that are in both lists, and you identify the number in both lists that is the greatest, the biggest or greatest. And boom, you got it. It's 4. But as this guy knows, 1, 2, and 4 are common factors of 8 and 12. He can also do it this way, which is, I don't know the name of this method, but it kind of, I won't say it scares me, but it's kind of interesting. So let's go through it. Step 1, divide 8 and 12 by a common factor, any common factor. So they wrote 8, 12, and they put like a dividey guy, but like upside down dividey guy, and they put a 2 out here because 2 is a common factor. All right, well, it's 8 divided by 2. So when you divide by 2, you just cut it in half. So half of 8 is 4, half of 12 is 6. So 8 divided by 2 is 4, 12, just in case you didn't believe me. So can we cut those 2 in half? Do they have a common factor, 4 and 6? Yeah, 2. They're both even. So half of 4 is 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Half of 6 is 3. So we've got these 2 as our common factors. And then you multiply the common factors. So 2 times 2 is 4. 4 is the greatest common factor. Wow, that's so much fun. I think I'm going to do one like that. So let's do one. So they want method 1. Ha! You can do method 1. I'm going to be here doing method 2. So let's figure it out. Okay. 16 divided by 8 is 2. 48 divided by 8, let's see. 6, right? 8 times 6 is 48, right? Okay. So can I repeat the process? Yeah, they're both even, so I could divide them both by 2, I think. 2 divided by 2 is 1. 6 divided by 2 is 3. All right, now, do these two numbers have any more common factors, 1 and 3? Nope. They are what's called relatively prime. And in fact, they're also both prime. But more to the point here, they are relatively prime because they do not share common factors, which means I must be done. So the common factors are 2 and 8, or at least the ones that are important for us here. And then 8 times 2 is 16. So I guess my GCF, my greatest common factor, would be, that's right, 16. Hey, it was one of the two numbers. It should be noted, if you do it this way, it doesn't give you all of the factors in a list because so both of them have more common factors. Like you could say 4 is also a common factor, but it didn't show up here. This is kind of a faster method if you're just looking for the GCF. So GCF is 16. Hot diggity dog. So number 21 is probably pretty self-explanatory. Identify prime and composite numbers. Well, let's get it over with because we're so close to being done. So identify prime numbers and composite numbers. Those are vocabulary words, very important. So here's another factors example. Find all the factors of 5. Well, we know that 5 is equal to 1 times 5, and that's it. So the factors of 5 are just 1 and 5. So here comes a definition. I'm going to hit you with a definition right here, so watch out. A prime number has only 2 different factors, 1 and the number itself. 5 is a prime number. So prime numbers are numbers that only have 1 in themselves as their only 2 different factors. So you might be like, well, why do I care about that? It's so interesting. Prime numbers are very interesting. There's no real pattern of them, but mathematicians spend a lot of time trying to look for patterns in them, and we still can't find them. We'll do a lot of cool stuff with prime numbers. The opposite of a prime number is a composite number. Kind of, you can hear the word compose in composite, maybe. So 12 is an example of that. The factors of 12, well, you do have 1 in itself because that works for every single number. But 12 is an even number, which means it's also divisible by 2, which means that it's got 2 as a factor, and then 2 times 6 is 12. And then 12 also has 3 as a factor, because 3 times 4 is 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. In fact, there are so many nice factors of 12, it's kind of like a nice reason why we divide clocks up into 12. Like there's 12 hours, and then there's another 12, right? Kind of cool. Kind of cool. So a composite number has more than 2 different factors. 12 has 6 factors, my gosh. So it is a composite number. Find all of the factors of 1. 1 times 1 equals 1. The number 1 has only 1 factor, which is 1 in itself, but itself is 1. Therefore, math geeks like myself like to say that 1 is neither prime nor composite, but if any teacher ever asks you that, come on. Why? So find all the factors, then decide whether the numbers are prime or composite. So let's do it for 21. Well, for 21, let's go to the other thing. Pew. So got to find the factors of 21. This is problem number 22 in learning. So I make my little T-chart, and let's do it systematic like. That's it. That's all. So 1 times 21 and then 3 times 7. 2 is not going to work because it's not an even number, so I knew to skip 2. So I asked myself, is this prime or composite? Well, it has more than just 1 in itself as factors. It also has 3 and 7, so it is a composite number. Composite number. Next one is 33. Oh my gosh, did you see that here? Okay, 33. Well, that's it for that one. Oh, you didn't see that. That's it for that one. 1 times 33 and 3 times 11. That's more than just 1 in itself, so it's another composite number. All right, number 24 is the number 59. Confused you yet? Okay. Well, I know I got 1 in 59, but I'm pretty sure that's it. So 59 is a prime number. Whoops. Sorry about that, folks. Ah. All right, next one, 77. So it's got at least 4 factors here, 4 unique factors. And yes, it's a composite boy. Yep, composite. Let's see what's up next. It's my favorite activity. Hopefully we're doing this live right now, or we just did it. How do you find the prime numbers from 1 to 20? Ugh, 1 to 20, no. We're going to do 1 to 100. Step 2, ask your partner to find the first number after 2 that has not been crossed out and underlined. It is the next prime number, then cross out all the greater numbers. All right, well, this is sort of, all right, well, 2 is a little bit better. The sieve of Erethoth, something like that, blah, 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 blah. And that will bring us to Let's Explore, which I guess we're probably going to do some other point, probably tomorrow as well. And then Let's Practice is your homework from the book. What homework from the book and the workbook? That's like double homework. Whoa. Yep, you have infinite time. Deal with it. So you're going to do 1 through 16. And you're going to do 17 through 23. And I guess that's only really for 4th grade because I guess the other grades don't have that. But regardless, I'll make it available. These are the steps to find the factors of 12. Oh my gosh, so interesting, so interesting. Hopefully we're doing all this stuff, which will bring us to next lesson, multiples. All right, thanks for sticking in there for half an hour. Hopefully we watch this tomorrow.